it's Mrs. Pound, and we're on the final section of Chapter 2.2 on soil. And that section is about fossils, Section 225. This is a topic that fascinates a lot of us, right? So, we are going to distinguish among different methods by which fossils are formed and describe how scientists use fossils to interpret Earth's physical history. So, the first thing we need to know is what is a fossil? These are the preserved remains or impression of an organism that lived in the past. Now, really important note here, very few species are in the fossil record. We tend to think that all of them must be in the fossil record, but there are not that many in the fossil record because there are two general conditions needed to form a fossil. First is the rapid burial and hard parts. Because hard parts decay slower than soft tissue. And also you need a rapid burial so that the organism does not decay before it becomes fossilized. So one of the most common fossils you find, and I'm sure you've all found this, is clams. You've probably all found fossilized clamshells, and that's because they meet the criteria. They were buried rapidly and they have hard parts. So there are lots of ways that fossils can be formed. So fossils are usually found in sedimentary rock. This is because if it was igneous rock, they're melted before they're formed, so not really likely. And metamorphic rock, remember that high heat and pressure would distort them. So usually found in sedimentary rock. The most common form of fossil that you will find is the mold and cast. And they are formed when dead plants and animals are buried by sediment on the sea floor, and the hard and soft portions of their bodies chemically change or dissolve away, leaving no original or an altered material. A hollowed out impression called a mold is left in its place, and then minerals may fill this mold to form a natural cast. This is the same idea as if you've ever used, say, a chocolate mold. Okay, the chocolate mold is a hollowed out cup that you then put the chocolate in to form the cast to get chocolates. Another way that fossils can form is through petrification, and the most common thing you've probably heard with this is wood, but other organisms can petrify as well. This is a process in which the organic portion of an organism is infiltrated or replaced with the minerals. Basically, the minerals go into the cells and take over the cell. Okay, so if it's a plant, it goes into the cell and takes over inside of the cell walls and replaces that organic material. There's also freezing soil and ice, so mastodons and other creatures that lived in the past in very cold areas. We will find these in Siberia and places like that. You can find them still frozen in the soil and ice. We've even found human beings frozen. Okay, and they're preserved very well when they're frozen. Tar pits. Things would fall into tar pits and became preserved. Now, actually, let's go back here. Fossils that are frozen in soil and ice cannot be older than the Ice Age. Okay, there cannot be older than the Ice Age, so I want to point that out. Tar pits also tend to be more from the Ice Age. The animals would fall into the tar pits and then become preserved. And we have many fossils from that. Natural resins. These are, a lot of times you'll see insects that are encapsulated in what we call amber, which is plant resin that has solidified and hardened and become a fossil. Then there are trace fossils. This is a fossil of a track, trail, or burrow. So this is not the animal or plant itself. This is evidence that it was there. And here we see a dinosaur track. So this would be a trace fossil. There's also desiccation. This is a type of fossilization where the organic material becomes dehydrated. This process is basically used for mummification. That's why I have the picture of the mummy, because I didn't really have a good example of a fossil that was this way. But especially in very dry areas, desert areas, the organism can become dehydrated and then it will be preserved. And that's why mummies, the Egyptians, were in a very dry environment. So they used desiccation to preserve the dead bodies in their civilization. Then there are also, this is not the formation, but let's talk now about how fossils are used by scientists. So there are some fossils that are called index fossils that they use. This is a fossil that is useful for dating and correlating the strata in which it is found. In order to be an index fossil, scientists have to determine that it is found for really a very short period of time in certain layers. You would not want a fossil that is through the whole fossil record, because then it doesn't give a date for the layer that it is found in. Now, this technique is used by old Earth scientists, not young Earth scientists, because old Earth scientists think that those layers were laid over millions of years, okay, and that different organisms lived at different times in those layers. A young Earth scientist believes that most of those layers were laid down in the flood, so they would believe that most of these fossils were the same age because those layers got laid down at the same time. They would have said that, yes, of course, we see mostly marine organisms at the bottom because those were the first affected by the flood, so they would be in the first layers put down by the flood. Then, as the waters rose, it started to affect organisms that lived on the land, and so then that's why you see them in the upper layers, because they would have died later and been deposited later during the flood. So this is an old Earth scientist technique. Old Earth scientists assume that fossils are the same relative age as the strata layer in which they are found. Okay, one thing I want to add is that on pages 8 and 9 of your Earth Science reference tables for New York State, there are some of these index fossils at the bottom of the page that are used for dating the different strata. And this is included with the geologic history of New York State, which would be an old Earth scientist view of the formation of the Earth. So that's why it's included there. But if you wanted to see what some of these index fossils are, you would find them there. So scientists use fossils to explain different events in Earth's history. They can theorize what the climate was like, how organisms interacted with one another, and what plants grew in a particular area by examining the fossils found in a layer of soil. Scientists also use fossils to assign relative ages for different strata where the fossils are found. So again, assigning the relative age would be definitely old Earth scientists. I think both old Earth and young Earth scientists would be able to theorize about climate and how the organisms interacted with one another from the fossil record. That would be something that they both would agree on, because obviously these things lived at a certain time. We know that certain plants need a certain climate or certain animals, so they would agree on this, but not on the relative dating. So our objectives are to distinguish among different methods by which fossils are formed, and to describe how scientists use fossils to interpret Earth's physical history. So this is it for the chapter. Don't forget your 5 questions and start studying. You have everything you need for the test.